Hello students, in this video we are studying amines. It's the first video of the playlist, and in this we will be discussing basicity of amines. In order to follow with the full playlist, make sure to subscribe to the channel Chemistry Crux, right? So let's start. Amines as Levy's bases. Amines as bases, and let me say amines are Levy's bases. What are Levy's bases? Levy's bases are something that can donate electrons, right? So how are amines Levy's bases? They are Levy's bases because they have a lone pair of electron on nitrogen. For example, if I take R and H2, fine. Here you can see it's a primary amine, and here you can see this lone pair of electron is available for donating, right? So this nitrogen can donate this lone pair of electron and thus act as a Levy's base. Similarly, we can have secondary amines as well, R and it's H. So you can see here also the lone pair is present, and in tertiary amines as well the lone pair is present. So the lone pair is present in all primary, secondary, and tertiary amines, as a result of which they act as Levy's bases, right? Now, what does this Levy basic character depend on? It depends simply on the availability of electrons for being donated. So more the electron density on nitrogen, more basic the amine will be. So simply it will be depending on first of all the plus I effect, that is the plus inductive effect, positive inductive effect shown by the R group. For example, this is RNH2. This R will be pushing electrons or giving electrons to this nitrogen, as a result of which electron density on this nitrogen will increase, so its basicity will increase. Similarly, we can have R and H. It is a secondary amine. Here you can see two I plus I effects are operating, so it will be more basic than the primary amine. Similarly, we can have a tertiary R group, which this will be replaced by R, and 3I plus I's will be operating. But it is a discussion for later. Let's first see what are the other effects that determine the basic character of amines. So the other is solivation effect, which produces hydrogen bonding, right? For example, if we add this group to H2O, that's a solvent, that's a protic solvent. So this nitrogen will be forming hydrogen bonds with this H, and also if there is some H, let's take this as H only, right? Then this H will also be forming hydrogen bonds with this oxygen, right? So this will be stabilizing this amine in this form, as a result of which this electron will be less likely be donated. Why? Because this is stabilizing it in the form, which we will discuss in detail in the further slides. Let's first see the third effect, that is steric effect. For example, if H positive comes and wants to take this electron pair from nitrogen, this R will be providing some steric hindrance. Also this R, in primary amines only this R, right? So this will be decreasing the basicity of amines. If we see the effect of these three, this one will be increasing because this will increase the electron density. This one will decrease because this will decrease the electron density on nitrogen, and this one will also decrease because this will not allow any species to come and take the electron pair from nitrogen, right? This will also decrease. So these are the three effects, fine. After this, if we see basicity of alkyl amines in gaseous state, fine. So let's discuss that. R and H2, this is a primary amine. Let me take a secondary as well. R and R and H is here, right? And the tertiary one will be R and R and R. Fine. These are the three amines, tertiary amines, that will be primary, secondary, and tertiary. Fine. So let's see what is the going on process. What are the processes going on, right? Here you can see only one group is causing the plus I effect. So this one is increasing the electron density on nitrogen. Here two R groups are increasing the electron density on nitrogen due to their plus I effects. Two plus I effects are operating, we can say that, right? And in this case, three plus I groups or plus I effects are operating. Plus I, plus I, and plus I. Fine. Now what is going on is that here the most electron density will be found. Here intermediate electron density will be found, and here least electron density among the three will be found. So this will be most basic, because in this more electron density will be there and it will be more donating its electrons. This will be intermediately basic than the two, and this will be least basic, right? This one will be least basic. So the order of basicity and gaseous state of alkyl amines is tertiary being the most basic, secondary being intermediately basic, and primary being the least basic. This order should be remembered in gaseous state only. Right. After this, let's go for the only plus I. Here you can see only plus I is operating. Let me erase this portion. Right here, only plus I is operating. So as a result of which, order is as expected, that is plus I, plus that is primary is least basic and tertiary is most basic, as explained, right? Now let's see the aryl amines, their basic character in comparison to alkyl amines. If we see this an alkyl amine or NH2, let's take the primary one, and if we see and let's take an aryl amine, let's take aniline. Here you get something like this, and NH3. This an aryl amine named aniline. Fine. So in this, I said already that basic character of these amines, it depends on availability of these electrons on this nitrogen, right? So here we can see plus I is operating, it is increasing its electron density, as a result of which it can donate them. But in the aryl amines case, here aniline taken as example, we can see this electron pair will be involved in resonance, as a result of which, let's not draw all the resonating structures, let's draw this one only. Here you can see plus charge is created on this nitrogen. If we draw the second one, we can draw it like this. Fine. Here a negative charge, here a double bond, here is H2 already present. Fine, a plus charge is created on this nitrogen. So this plus charge means that there is no electron pair present. That is, for some time electrons are not present on this nitrogen, as a result of which they are less available for being donated, and this nitrogen acting as a base. So we can say that aryl amines are less basic than alkyl amines. Hope you understand the reason well, right? This is the reason, due to the involvement of lone pair of electrons in on nitrogen in resonance, we can say this particular statement. After this, let's go for basicity of amines in gaseous state, which I already discussed. Let's see, let me say that order is as expected, primary are least basic and tertiary are the most basic. After this, let's see basicity of amines in protic solvents. If we take our primary amine, our NH2 and H and H, then we take R, N, R and H, that is a secondary amine, and then R, R, sorry, R, N, R and R. Fine. If we take these three in water, let us say H, O and H. Here also let's take HO and H, that is water. In this case also we take water. We can see not only plus I is operating, this plus I, it is operating, we can say that But not only this plus I is operating, there are two more effects also taking role in this reaction. Let's also take H positives that will be furnished by water, because whole of the water will be furnishing these H positive and OH negative. The three effects, let me show you. The first I said plus I effect, right? Here also, let me take the marker. Here you see plus I effect, two plus I effects, and three plus I effects being operated. After this, not it is a plus I effect that is operating, right? Let's see the second effect that's there. That is this hydrogen bonding. There will be many of these water molecules. Here you can see three hydrogen bonds will be found: one, two, and also three. These will be with different oxygen atoms, but I'm showing you the single one, right? Also here you can see this will be forming one, and this will be forming hydrogen bonds with this. Here only one hydrogen bond will be formed with this, right? This is the second thing that's going on. So first was the plus I effect. The second thing that's going on is hydrogen bonding. That is due to the solvation. All right. After this, the third one that's going on is the steric hindrance that will be provided to this H due to this R. Fine. This R will be providing steric hindrance to this. Here also this one will be providing, and this one will be providing steric hindrance to this R. So the third effect that is there is steric hindrance. These three will produce an additive effect, and that will give us some basicity order, which will not be as expected, right? Which will not be something like primary, secondary, and tertiary. It will be something different from this, and it will be an additive effect of these three. For example, if we replace this R with C2H5, that is ethyl group, we get the order something like this. We get secondary being least, and primary being the most, and tertiary being intermediately basic, right? This is something which you have to cramp because it is experimental and it cannot be you know given some reason. The reason is there, but it's not something that can be remembered. The reason is that it is that cannot be conceptualized. It cannot be conceptualized. It can be only said that the reason for this is the additive effect produced by these three groups. These three, that is inductive, hydrogen bonding, and this steric hindrance, right? Similarly, if we replace this R group with what we call as CH3, that is methyl group, we get the order of this thing: secondary being least and tertiary being most, right? This is something you have to remember on your own. You have to cramp it down. So this is the order: 2 1 3 for CH3 and 2 3 1 for C2H5. Fine. Let's revise the whole concept. The first thing was uh, they are Levy's bases because of the electron pair that is present on nitrogen. Fine. The second thing is basicity depends on plus I effect. Number two, side sorry. Number two, solvation, right, which is hydrogen bonding being coming into play. And the third thing that is there is uh, steric hindrance provided by the R groups. Steric hindrance. This plus I effect increases, these two decrease the, this increase the basic character, and these two decrease the basic character of the amines. Fine. After this, we studied about the um, basic character of amine, alkyl amines in gaseous state, which we found as expected, primary being least basic, secondary being more intermediately basic, and tertiary being the most basic amine among the three in gaseous state, in gas state, right? Then we studied about uh, difference between, we also studied about alkyl amines and aryl amines. Aryl amines, we found that aryl amines are less basic than alkyl amines. Let's replace it with R, right? Aryl amines are more basic than alkyl amines, aryl amines, and H2. Fine. After this, we studied the basicity order of alkyl amines are NH2 in if this R group is replaced by CH3, that is methyl group, in which the order comes out to be 213, that is secondary, primary, tertiary, and if it is replaced by C2H5, the order comes out to be 231, that is secondary, tertiary, primary. And these two orders have been seen experimentally, and they are additive. They are produced due to the additive effect of plus I effect, steric hindrance, and hydrogen bonding. This is all about the basicity of amines that you need to know. Hope that clarifies everything. Make sure to subscribe to the channel and wish you luck.